Hello everyone, welcome to our channel Off Campus. In this video we are going to see some examples in differential equation to find out the solution of differential equation, that is particular integral and complementary function. Okay, previously we have solved many problems under differential equations. Kindly check with the playlist if you haven't seen those videos. Okay, let's start our session. First question, the PA of d squared minus 4d plus 14 equal to e power 2x. So, it is of the exponential form. For that exponential form, particular integral, in short we can say it as a pi. To find out pi, we can use the RHS. RHS is of what type? Exponential type. For that, just write that this function in the denominator, 4d plus 14. So, here what is d? D is replaced by e power alpha x, d equal to alpha, replace d by 2. Okay, then so just substitute e power 2x divided by 2 squared, 4 minus 4 into 2, 8 plus 14. What we will get? 14 plus 4, 18, 18 minus 8, nothing but 10, e power 2x divided by 10. So, this is the particular integral for this problem. Okay, so option 1 is the right option for this problem. We'll move on to the next one. Here we need to find out the complementary function for the given d power 4 minus 1 into y equal to 12 e power x. We need to find out the complementary function. To find out complementary function, what is the first step? Assume RHS equal to 0. Okay, this is the first step. Then this is f of d into y equal to 0. What is f of d here? D power 4 minus 1. Then what is the next step? To find out to form the auxiliary equation, in short AE. So, auxiliary equation to nothing but replace d by m, which is m power 4 minus 1. We need to assume RHS equal to 0 for finding out the complementary function. So, RHS equal, whatever it is in the RHS, we should assume it is 0. Okay, then find out the roots for this. This is m squared the whole square minus 1 squared. A squared minus b squared is nothing but what are all the roots? M squared plus 1 into m squared minus 1 equal to 0, right? So, find out the root. M squared equal to minus 1. Here m squared equal to plus 1. M equal to square root of minus 1, we will get around plus or minus I. Here m equal to plus or minus 1. Okay, 4 roots for m. So, we will have 4 complementary function. See, by taking this, the roots are plus 1 and minus 1, m1 and m2 equal to plus 1 and minus 1, plus 1 comma minus 1. So, roots are real and unequal. So, roots are real, but it is unequal. For that, what is the step? C1 e power x alpha x, nothing but e power x plus C2 into e power minus x. Then here see the roots, 2 roots over, again for C m3 and m4. So, plus or minus I, it is nothing but roots are complex conjugate. Complex conjugate, real part is it is nothing but C alpha plus or minus beta, I beta. Alpha part, the real part is 0 here, alpha equal to 0. What is beta? Beta equal to 1. Okay, for this problem. So, for roots or complex conjugate, what is the complementary function? E power alpha x. E power alpha is here 0. So, e power 0x into C3 a cos beta x plus b sin beta x. So, a cos nothing but C3 here. Whatever it is a constant, a or C3. Here according to the option, see here options are given in C1, C2, C3, C4. So, I am just writing C3 into cos beta x, cos, what is cos beta value? 1. So, cos x plus C4 into sin beta x, sin x. So this is the answer. Complementary function for this problem is nothing but c1 e power x plus c2 e power minus x plus this term. So what is the option? So c1 e power x plus c2 e power minus x plus c4 e cos x plus c5 c3 c4, instead of they mention as c4 c5, it's okay, just we will just, it is a constant only. So c4, so e power 0x is nothing but 1. So this is the answer. Option 2 is the right option for this problem. Okay, then move on to the next problem. Wait a minute. So this one, the solution of d squared plus 4 into y equal to pi. The solution means we need to find out the both complementary function and particular integral as well. Previously what is asked for first problem, particular integral unknown. For this problem they need to find out the complementary function itself, only complementary function. So in his mentioned solution is nothing but we need to find out the complementary function and particular integral as well. Okay, first we need to find out the complementary function. For complementary function we need to assume RHS equal to 0. So d squared plus 4 into y is nothing equal to 0. This is nothing but f of d into y equal to 0. Okay, to find out complementary function. Then what is the next step? To form the axillary equation. For what is the procedure to form the axillary equation? Just replace d by m. So m square plus 4 equal to 0. Then find out the roots for m. So m squared equal to minus 4, m equal to plus or minus 2i. See, this is then see the roots m1 and m2 are what is that? Complex conjugate. It is like alpha plus or minus I beta. What is alpha here? Alpha is 0 and beta equal to 2, right? From this. So what is the procedure? To e power alpha x e power 0x into a cos beta x. A cos 2x plus b sin beta x. B sin 2x, beta value is 2. So this is the complementary function. Say it is a equation 1. Then we need to find out the particular integral. To find out particular integral, we need to use the RHS. So to find out particular integral, we need to use the RHS pi divided by d squared plus 4, this function. So here nothing is here, we can substitute here as e power 0x. See, e power exponential power anything is nothing but 1 only, so it will not affect. So pi e power 0x. So just replace d by 0. Okay, e power alpha x, alpha value here 0. So d, replace d by 0. So what is that? E pi, we no need to repeat this because this value is 1 only. So 0 plus 4 we will get 0 square plus 4 we will get pi by 4. So it is the particular integral for this differential equation. So what is the solution? Solution y equal to CF plus PA, just adding 1 and 2, complementary function plus particular integral. So a power 0x is also 1, so no need to write. A cos 2x plus b sin 2x plus pi by 4 equal to y. This is the solution for the given differential equation. Option 1 is the right option. Then move on to the next problem. We need to find out the particular integral for the given problem. To find out particular integral, we need to use the RHS. RHS is of exponential type. So 6 e power 3x divided by this term f of d. D squared minus 6d plus 9. Just replace d by 3 here. Okay, coefficient of x. So just substitute c6 e power 3x divided by 3 squared. 3 squared is nothing but 9 minus 6 into 3 nothing but 8 plus 9. So what we will get? 9 plus 9 8, 18 minus 18 0. So we will get numerator term divided by 0. So the whatever in denominator part will be 0 means in denominator we have 0. So, what we will get, anything divided by 0 we will get infinity. So, it should not be infinity, it is absurd. We should proceed. For that, if anything, this is the special case, if any in denominator term we will get 0. If we get 0 in the denominator, what we need to do? Just do one substitution. So, substitution is nothing but multiply by x in numerator term and differentiate denominator term. So, this is the shortcut to proceed the next step. Whenever we will get 0 in the denominator, this is the procedure. As I told earlier, we have explained very clearly in our previous videos. So, kindly check with the playlist under engineering mathematics. We have solved many problems. Okay. So, in this case, see, multiply by x in the numerator and differentiate denominator. So, this case, see, this term, we are getting 0 now, 6 e power x, 6 e power 3x d square minus 6d plus 9, right. So, multiply by 3, sorry, x in the numerator. So, 6x e power 3x and differentiate denominator. Denominator term differentiate, what we will get? 2d minus 6, this is a constant, we will get 0. So, this is the derived one. Then we need to substitute a d by 3 and then proceed. Okay, d by 3. So, 6x e power 3x 2 into 3. So, here in 2 into 3, 6 minus 6, again we are getting numerator, in denominator part we will get 0 only. So, again we need to follow this step, multiply by this step. In this step also we are getting 0. So, again multiply by x in the numerator and differentiate the denominator term. So, in this step multiply by x, 6 x squared e power 3x by differentiate the denominator term 2 only. Okay, this is a constant 0, when we differentiate in 2d we will get 2 only. So, this is the answer. So, there is no further simplification. So, cancelling this 3, 3x squared e power 3x. This is the particular integral for the given problem. 3x squared e power 3x. Similarly, 3x squared e power 3x, option 3 is the right option. Okay. We'll move on to the next one. We need to find out the particular integral for the given problem. Particular integral. See, we need to use RHS log 2 divided by the f of d. Given term d square minus 6d plus 9. So, here nothing is here. So, we can substitute e power 0x. So, already we have done one problem now. So, e power 0x will not going to affect this equation because anything power 0 will 1 only. So, multiply by 1 will not going to affect this term. So, e power 0 say. What is the next step? What is replacing term? D by 0. So, whenever we are replacing 0 in place of d, e power 0x we can leave as it is 0 square 0 minus 0 plus 9 only. So, log 2 by 9. So, particularly it is very simple, by substituting 0 we will cancel this term, then log 2 divided by 9. So, which one? Log 2 by 9 is the right option, is the solution for the given problem. Log 2 by 9, option 3 is the right option. Then we move on to the next problem. We need to find out the particular integral for the given problem. For that we need to use 3 power x. Use RHS, then divided by f of d, d square minus 6d plus 9. Okay, this is C, 3 power x. So, we can do one substitution, like we can do like this, right? See, e power log 3 power x. Whether it will be going to affect this term. So, previously see what is the difference. Previously there is no x term. So, we just substitute e power 0x, because now see 3 power x. For 3 power x, we should do one thing. Exponential term and logarithmic term get cancelled. So 3 power x will be 3 power x. So this term will not be going to get affected in any way. So e power log 3x is equal to 3 power x only. So it is a log a power b. It is in the form of log a power b. So what we can write? Log a power b log a, right? X log 3. Okay, this is a basic logarithmic formula, d square minus 60 plus 9. Okay, we can further write it as, so e power log 3 of x. So d minus 3, we can write it as d minus 3 the whole square. So d minus 3 the whole square is nothing but d square minus 60 plus 9 only. So e power, what we need to do? We need to replace d by e power alpha x. What is alpha here? Log 3. So replace d by log 3 here. So e power log 3 x divided by log 3 minus 3, in place of d substitute the whole square. So this one. So again when we doing simplification, e power log 3 we can just substitute this one, e power log 3 power x, we will get x log 3 only. Now this and this will get cancelled. We will substitute just 3 power x divided by log 3 minus 3 the whole square. Okay, this one 3 power x, this is 3 power x log 3 minus 3 the whole square. Option 4 is the right option for this problem. Okay, we'll move on to the next one, particular integral of the given function. So we need to use the RHS. So see, the RHS is the type of exponential function divided by f of d power 5 minus d. So here d equal to e power alpha x is nothing but 1, just replace 1. So e power x divided by 1 power 5, 1 only, 1 minus 1 we will get numerator term divided by 0. So whenever 0 comes in the denominator, what we will do? Multiply by x in numerator and differentiate denominator. So this term, okay, multiply x, multiply by x, what we will get? X e power x. So differentiate the denominator, 5 d power 4 minus 1, right? Now substitute d by 1. So just substitute d by 1 in the denominator. Okay, pi equal to x e power x divided by 5. 5 minus 1, d power 4, 1 only. So 5 minus 1, 4. So x e power x by 4. Pa equal to x by 4 e power x. So same thing, x by 4 into e power x. Option 2 is the right option for this problem. We will move on to the next one. What is that? Particular integral for the given type. Given type is nothing but in right hand side we are having exponential term. So e power minus 2x divided by f of d, this term, d squared plus 4d plus 4. Then what is the next step? Substitute d by minus 2. So e power minus 2x divided by minus 2 the whole squared, what we will get? 4 plus 4 into minus 2 minus 8 plus 4. So what we will get? 4 plus 4, 8 minus 8, we will get numerator term divided by 0. So we should not proceed like this. Whenever we denominator term will get 0, we should use what is the type? Multiply by x in numerator and differentiate denominator, right? Differentiate denominator, this term e power minus 2x. So multiply by x e power minus 2x, differentiate denominator 2d plus 4. Then we need to substitute d by minus 2. So whenever substitute minus 2, what we will get, ma? 2 into minus 2, what is? Minus 4 plus 4, again we are getting numerator term divided by 0. So again we are doing this thing in this, okay. multiply by x in the numerator. So already one x is there. So x into x squared e power minus 2x, and differentiate denominator 2d is nothing but 2 only. So x squared by 2 into e power minus 2x. This is the particular integral for the differential equation. So x squared by 2c into e power minus 2x. Option 1 is the right option for this problem. Okay. We'll move on to the next one. PA. So we need to use the RHS exponent e power minus x divided by f of d, the given term d square plus 2d plus 1. Then what is the next step? Replace d by minus 1. Okay, just replace minus 1. What we will get? Minus 1 the whole square 1. 2 into minus 1 minus 2 plus 1. So 1 plus 1 2, 2 minus 1 2 minus 2 0. So numerator term divided by 0. Whenever denominator term will be we will get 0 as a denominator. What we need to do? Multiply by x in numerator, differentiate denominator, right? So PA equal to, I am writing here, PA equal to in this equation. So multiply by x in the numerator x e power minus x, differentiate denominator 2d plus 2. This is a constant, we will get 0. So what is the next step? Just substitute d by minus 1. Okay. D by minus 1, what we will get? X e power minus x, 2 into minus 1 minus 2 plus 2. Again we are getting numerator term divided by 0. So we need to do again the same thing. Okay. Multiply by x in the numerator. So x squared here. X squared into e power minus x. Then differentiate denominator. Denominator term differentiating will we get 2 only. So x squared by 2 into e power minus x. So x squared by 2 into e power minus x. This is the right option. Option 1 is the right option for this problem. This is the last and final problem in this video. Okay. So same thing, we need to find out the particular integral. So e power x use RHS divided by the f of d term, given term d cube minus 3d squared plus 4d minus 2. So what is the very first step to find out the integral when it is exponential type? Just replace a d by e power alpha x, d by alpha. So alpha is nothing but 1. So just substitute e power x divided by 1. Substitute d by 1, 1 minus 3 plus 4 minus 2, adding plus term 5, 1 plus 4 5, minus 3 minus 2 minus 5, plus 5 minus 5, we will get 0 only. So numerator term divided by 0. Then what is the next procedure? Multiply by x in numerator and differentiate denominator. Okay. So this is the shortcut. So do this here, x e power x divided by differentiate. So 3d squared minus 6d plus 4. Then what is the next step? D by 1. Okay. Then x e power x divided by 3 minus 6 plus 4. 3 plus 4 7, 7 minus 6 1, x e power x divided by 1 only. So what is the simplification? X e power x. This is the particular integral for this problem. So x e power x, option 1. Option 1 is the right option. Okay. So this is the procedure to solve this. We have solved many problems under differential equation as I said earlier. So kindly subscribe our channel Off Campus and then click on the bell icon. Then only you will receive notification whenever we upload videos. Okay. We will solve more and more problems under differential equation in our upcoming videos. So please stay tuned.